I thought what I'm going to do today is go over the worksheet that I gave you. Everything here is pertinent to analytical geometry and the straight line. Remember, the straight line you will always also find in paper 1. So it's actually very important. All right, you just got to be quiet on your side. Turn down speakers, guys. Angels, it's too noisy on that side. Right, that's better. All right, I will post the memo when I'm finished, so you don't have to profusely copy it down. Just watch and make sure you understand it. All right, if I look at question number 1, basically they said, can you give the equation of a straight line? They gave me 2 clues. Clue number 1, they said, my line is perpendicular to this line, 2y plus 4x equals to 3. And clue number 2, they told me that my line goes through the coordinate -2, 3. Alrighty, the perpendicular, remember, you're always thinking of gradients, but you've got to get the equation into standard form before you can look at the gradient. Remember, you want a ghost plus 1, y, equals to mx plus c. So in other words, the coefficient, right guys, the coefficient of the x will give you the gradient of their line, but you need to have a ghost 1 in front of the y. So do you agree they have 2y? If we take this term across, do you agree equals to -4x plus 3? So if you divide everything through by the coefficient of y, so that we get a ghost plus 1y equals to -2x plus 3 over 2. That would look something like that. Now, my line coming in perpendicular, all right, listen carefully, whether it's there or here, if it's perpendicular, can you see it's coming from the reverse direction? So, a line perpendicular, you must remember, you reverse the sign of the original gradient. You're just looking at gradient of theirs to the opposite, and flip it upside down. So we say it's the negative reciprocal. I said this yesterday, reciprocal means upside down, and negative meaning if you times the original gradient by -1, the sign of the gradient reverses. All right, now if you draw 2 lines perpendicular, not that I'm saying these are the exact 2 lines, but can you see they're cutting the y-axis in totally different places? So I'm not interested in the y-intercept of their line. I only want you to get their line into standard form to see what the gradient was, so I could work out the gradient of my line, which is perpendicular to their line. All right, so my line, I know the gradient is +1/2 x, but I must find out what my y-intercept is. It might be up there or it might be down there. I haven't visually drawn it correctly, but I'm just trying to show you algebraically. My line goes through the coordinate where x is -2 and y is 3. So what have I taught you? That any point that lies on any graph, you sub the x into the x, and you'll put this y value into the y. So 3 equals 1/2 times x, and x is -2 over 1. And you agree we can actually solve this because that divides into itself once, 2 divides once, so we have -1 plus c. So c is going to bring that across 4. So my line is going to be y equals 1/2 x plus 4. So the top diagram was more accurate. If I were drawing this, that would be my line. My line, the gradient is going like a tick positive, and you see the y-intercept would be up there, let's say at 4. Okay, So I'm going to send you the memo. So Muni panic me. I'm going to carry on with the questions. Okay, so that was question 1. Right. Now, question 2 is quite a common exam question where you get a whole lot of coordinates. So the coordinate of A is -2, 3. The coordinate of point B is 1 and 4. The coordinate of point C is -4 and 1. And the coordinate of D, X is unknown X, but Y is -3. And then they ask you a whole lot of questions, right? So the first question is going to be a straightforward level 1. Can you determine the equation? Now they want the equation of the straight line AC. Now we know a straight line is y mx plus c. So it's got to go through point A and through point C. So we're only interested in those 2 coordinates. Do you remember you get the gradient of the straight line if you have 2 coordinates, A and C, that lie on the line, by taking the difference of the y of the coordinates divided by the difference of the matching x values of the coordinates. Okay, so the gradient of AC, if you're clumsy, careless like me, just sometimes go x, y, and you won't go wrong. So I'm going to start with the y of the one coordinate minus the y of the other divided by the x of the starting there minus the x. And again, be careful when you're minusing a minus. So the gradient of the line AC equals to 1 minus 3, which is -2, over -4 plus 2, which is -2, because that becomes a plus 2. And minus over minus is just positive, and you get 1. So if I have not made a mistake, my gradient is plus 1x. Well, the gradient is plus 1. Then you put x plus c. Now, either point A or point C lie on the graph, so you can sub in either. Let's say we decide to sub in point A, x is -2, y is 3. So you put the x into x. You put the y of the coordinate into y. So we're going to get 3 equals 1 times -2 plus c. So 3 equals to -2 plus c. So c is going to be +5. So y equals to +1x plus 5. Guys, if your gradient is a ghost plus 1, then you don't need to show the plus or the ghost 1. It's a ghost. Now, because I don't want to confuse you, I'm just going to look at my memo each time and make sure I did it correctly. Because if I confuse you, you can't really ask me, so you'll be more cross than ever. Yeah, that is the correct answer. So we've done 2.1. So on average, 3 marks, 1 for getting your gradient, 1 for subbing in a coordinate that lies on your graph. And remember, I could have subbed that one in, and 1 for your final answer. Okay, I'm going to erase out that. Remember, I'll give you the memo. What's the next question? Okay, the next question, let's just take those 2 crosses away. 2.2. Can you please find the equation of a line parallel to AC, but which also goes through the point B? Now, if I've got a good memory, the gradient of AB, no, it was AC, sorry, so much for the good memory, is the one we just found. And I do remember it being +1. So the gradient of AC is +1. We worked that out in 2.1. Now, if 2 lines are parallel, the slope is going to be the same. So do you agree that the gradient of a line parallel would be exactly the same as the gradient of the line given, which is parallel to the line I want? So this is the only time in life you allow to steal something. So parallel straight lines, you steal the gradient. So the gradient will be exactly the same, but again, if I were to put in the y-axis, just to prove to you the y-intercept, which is the plus c, which obviously if c is negative, could be negative, but it's not the same. Do you see? They're not the same. So the only thing that is the same of parallel lines is the gradient. But they gave me another clue. The line they want me to find goes to the point B. Now the point B, they gave me the coordinate 1 and 4. So that lies on the line that they want me to find. So we're going to sub the x1 into x, the y of the coordinate into the y, and you want to find the little c, which is your y-intercept. So we're going to put the 4 there equals 1 times 1 plus c. So 4 equals 1 plus c. So c is going to be 4 minus 1, which is 3. So again, if I'm not mistaken, that should be my final answer. Notice the gradient is positive goes to 1 and then x plus 3. Let's see if I did that one right. Okay, 2.2, y equals to x plus 3. Yes, you've got a clever math teacher, hey? She's getting everything right. Well, so I should. Haven't made my deliberate careless error yet, guys. It's coming, it's coming. All right, let's look at now 1.3. I'm meaning there was a little error, but I fixed it myself, 2.3. All right, oh, lovely question. Can you please determine the value of x? If, then they tell me the line AB is perpendicular to the line CD. Straight line AB is perpendicular to CD. There's x. Okay, so what is x? If the line AB is now perpendicular, you should always know in this section is to do with gradients. Please find me the gradient of the line AB and the line CD. Now remember, the gradients are not equal. The one is equals to the opposite side, negative reciprocals. In other words, I'll show you there's 2 ways you could do this, but let's just first of all get the gradient of AB. Do you notice how I'm setting that out? So my examiner can see I'm looking for the gradient of these 2 points. So the formula, as you know, you take the y of the one coordinate minus the y of the other over the matching x values of their coordinates. So if I start with 4 minus 3, then I must go 1 and minus 2. Okay, 4 minus 3 is just 1 over 1 plus 2 is 3. Now, let's quickly work out the gradient of CD. Now, please take note, there is going to be a variable x in this answer, okay? Don't panic. We know we take the y of the one coordinate of CD minus the y of the other over the x of the coordinate we started with minus the x of the other coordinate. And remember, be careful when you're minusing a minus. So the gradient of CD is negative 4 over x plus 4. That minus times minus becomes a plus. Okay, now guys, there's 2 ways to do this. So I'm going to do both. What I need to do though is just transfer the information. So the gradient of AB, we numerically worked out is a third, and the gradient of CD, even with the variable, we worked out is minus 4 over x plus 4. And the clue was these lines are perpendicular, solve for x. So to me, the easiest way to do this is I'll take the gradient of the more complicated one, which in my opinion is the one with the x. So I'm going to go minus 4 over x plus 4. Remember everyone, a division line is a flat bracket, so put that in a bracket. Now if I had said they're parallel, I would make that equals to the other gradient and solve the equation for x. But I didn't say they're parallel, I said they're perpendicular. So method 1 is you make it equals, then take the other gradient, reverse the sign, and flip it upside down. So I've changed it to the opposite side and I've flipped it. Now they are equal. So remember, this is method 1 I'll show you quickly another way you could have done this. So now you have an equation. So we're going to cross multiply. So minus 4 equals minus 3 into the bracket of x plus 4. So minus 4 equals to minus 3x minus 12. Positive 3x, if I bring this across, equals to minus 12 plus 4. So 3x is going to be minus 9. No, I lied. Minus 8. 9, 10, 11, 12. Minus 8. Okay? And then to get x, you obviously divide through by the coefficient. So x is going to be minus 8 over 3. All right. So I'll just make a note I've done that right. X is minus 8 over 3. But I'll show you there's another way you might have done it. Let me just check I'm right. You often do get strange answers, so that doesn't worry me at all. So for 2.3 minus 8 over 3 is perfect. Okay, method 2, let's say you did not do that. Okay, I don't know why I just used my hand when I have an eraser. It smudges the board, and now my hand is contaminated. So before I move on, let's just disinfect that. Okay. All good, all good. Okay, now remember, there was a second way to do this. So I'm going to share with you the second way. We found the 2 gradients. Of, let's say, the 4 marks, you have at least 2 out of 4 by just getting the gradients, which means you have a government pass with 50%. But some of you know that the gradients of 2 lines that are coming in perpendicular, if you times the 2 gradients, you get a -1 product. Now, some of you know that. So I think method 2, a lot of you would have taken the gradients of the 2 lines, and perhaps you would have times them together, but then you keep the original gradient of +1 over 3. And because you know that equals to -1, so method 2, you could have set up your equation like that. We should get the same answer. So because this needs to be multiplied first, you're going to go top times top over bottom times bottom. So I'm going to get -4 over 3 into the bracket of x plus 4 equals to -1. Put that over a ghost 1. Cross multiply. So 1 times -4 is -4 equals to, so we're going to go minus 3x minus 12. We cross multiplying. Just be careful there. If I bring this over, I get positive 3x, which will be minus 12 plus 4. So x is still going to be minus 8 over 3, which is what I got the first time. I prefer method 1, it's faster, all right? But you can choose. Okay, there's one more question. Question 2.4. Now, question 2.4 is also solved for x, all right? But they're giving me new information. So because the information is different, the value for x will be different. This time they're saying, can you please find the value of x if the points A, C, and D are collinear? Now, you should have done this last year, but if I have a straight line, if points are collinear, I'm just making this up, I haven't even plotted those points, but collinear points, then it means they lie on the same straight line, okay? And because the gradient is always constant between any 2 points on a straight line, and the gradient being the rise over the run, it would be constant, all right? We always solve collinear questions using gradients. Because the gradient, just think about it, let's say from A to C, would have to equal the gradient from C to D. Because it's a ratio, I mean, you can think about it, I've gone 1 up. If I went 1 more up over 1 over 1, you see, I still get the same constant ratio. So that's what collinear points mean. They lie on the same straight line. So if they say, okay, we've got point A there, C there, and D. They're telling me they're collinear, so they're saying solve for x. So we know to use gradients. So just get the gradient, as I said, of AC, which is 1 minus 3. So I'm going 1 minus 3 over negative 4 minus 2. So if I just neaten that up, I get negative 2 over minus 4 plus 2, which is negative 2, which is positive 1. Now, because they're collinear, this gradient of AC, which is 1, by the way, if you were really concentrating, we did that in question 2.1, okay, would equal the gradient of CD. Okay, so we have minus 3 minus 1 over x minus 4. We've done that one as well. If you remember, we've actually got that. So here's your equation. All right? So we took the two gradients and we made them equals to each other for collinear. Don't panic with fractions. Remember, fractions with fractions, just cross multiply. So you're going to have 1 into x plus 4 equals 1 times minus 4 is minus 4. And then distribute in, well, that just becomes x plus 4 equals to minus 4. And according to this, x is going to be minus 8. But I don't remember that being the correct answer. So what I'd like to do is just before I look at my memo, see if I can find the correct answer, because I don't remember that being the answer at all. Let's just have a look here. The gradient of AC, CD. Okay, so I went 1 minus 3 over minus 4 minus 2. 1, well, the gradient of AC we know is 1. Done it. Okay, the gradient of CD, I've done that one before, I know that's right. Ah, there's my error. If I times the minus 2 by, oh no, sorry, ignore. Okay, guys, if you don't mind, I'm being stupid. I'm just going to go to my memo because I know that's not the answer. Just because I've done this question so many times in my life, I've made a mistake. I can't find it. Oh, don't tell me. Guys, they said it B, C, and D, and I'm using A, C, and D. Duh. All right, I would be right if they said A, C, and D are collinear. But you've probably been shouting at me since I started the question. It's B, C, and D. Oh, damn it. That changes everything. But listen, you will notice the method's the same, okay? I just, I've done this worksheet many times and I don't remember me getting 8. So you wouldn't have known you made a mistake, but guys, it's so easy just to copy down the wrong question. Am I right? If B, C, and D are collinear, okay? So I want to get the gradient of BC and make that equals the gradient of CD. Now, I've done this one before, so the gradient of CD, do you remember, was minus 3 minus 1 over x minus, so it became, we've done that quite a few times, minus 4 over x plus 4, okay? And then the gradient of BC, let's just quickly do that one. So I'm going to take this y minus this y, so 4 minus 1, but then what am I doing? I'm going 1 minus 4, then I'm just going minus 4 minus 1. So 1 minus 4 is negative 3 over negative 5. Before I cross multiply, do we all agree that's a positive? So I've got 3 over 5 positive equals minus 4 over x plus 5. So if I cross multiply, minus 20 equals to 3x plus 15. So 3x is going to equals to minus 35. So x should be minus 35 over 3. Now that's more like a strange looking answer, and I vaguely remember a strange looking answer. So let me just check that for you. So if I was doing 2.4 minus 32 over 3. Where's my error? It's a small error. We'll find it. Okay. I don't know. I'm having a bad day. Or you guys, I was watching the minister's speech and all the questions, and my mind's just not there. Okay. I'm just checking very quickly. So the gradient of BC, let's just look again. So it's 1 minus 4, done, over minus 4 minus 1, which is negative 3 over negative 5. Which, let's just check if I did that right. So if I look at 3 over 5, okay, that is right. the gradient of, you probably have found my mistake before I'm doing it, CD, so it's minus 3 minus 1 over x minus minus 4, which becomes minus 4. That's right. Oh my word! Oh my word, look what I did there. I changed the 4 there to a 5. Now, guys, 4 is not equals to 5. Okay. All I've said before in my life is if you make a careless error, they will continue accuracy. I would have lost 1 more. My slip, I would have only got 75% for my own question, which makes me feel very stupid. But minus 3x minus 12 equals to 20. So minus 3x equals to 32. So x is going to be minus 32 over 3. Let's see if that's what the answer was. I vaguely remember 32 over 3. And it is minus 32 over 3. Okay, so again, you can see that even teachers sometimes make stupid errors. I mean, I literally copied that down incorrectly, which is stupid. And I hope you noticed and were shouting out behind the camera that I did that. Okay, as I say, I'm distracted because I was watching the TV, the tele. Okay, now watching TV is not always a good thing. Hey, I've actually decided 5 minutes of global news, which is much more predictable and fun. News of the world. Okay, now we're going back to we're going back to what you did in grade 9, where it was such fun. Okay, where we had the y-axis crossover, and I gave a little graph here. Strategic coordinates, not drawn to scale. Point 1. The y-intercept is positive, x-intercept is positive 2. And I normally it's y equals mx plus c if it's a big. Now that's by inspection. I'll teach you how. Of running in that direction, I can n. So the gradient is negative. So the first thing I do is gradient is negative. The gradient is your rise over your run. In other words, it's the direction and the distance that we travel by the direction and the distance we travel horizontally. And that is why in the difference of any 2 points along the line over the difference of the horizontal x values. We can see the diagram, it's an n, the gradient. Just look at a right angle triangle, knowing the distance is always positive. The run is 2. So vertical 1 to 2. So it's minus 1 over 2. Don't forget to put the x, the y, 1. So I would have done that by inspection. Now there's some of you who just didn't get it that way. You axis, x is 0, y is 1, because that is the x equals 0 line. The x-axis, you know, is the y equals 0 lines. By using the formula. So 0 minus 1 over 2 minus 0 is minus 1 over 2. Except I think you can see us there. But I do inspection. All right, let's look at 3.2. Now, bringing a bit of trig into this. Okay. I gave you a straight line graph with a minus 1 y-intercept there. I told you, by the way, that's called the angle of inclination. The angle of inclination, if you put your pen on the x and you move anti-clockwise to where you hit your line, that angle is your angle of inclination. Now this is inclination. I'll do it later in the week. M for gradient equals tan of your angle of inclination. All right. It this way. Just have a look at this. Let's say this is the floor of the building and this is the second floor. Okay, and let's say we have steps. Poor guy in a wheelchair. Now, I'm drawing a wheelchair, poor guy. Okay, he can't walk up steps. So they'll have to make, do you agree with me? They'll have to make a ramp. So do you agree that the gradient of the straight line is the change in the y over the change in the x, which is this? And this would have to be perpendicular to be a from floor 1 to 2. Do you agree that tan, acute angle in a right angle triangle, is the opposite side over the adjacent? The opposite side is the vertical over the adjacent. So do you see that the change in the y from that to the x? So it's basically the gradient of the straight line equals tan of your angle of inclination. If then you can see that the gradient of the straight line will be positive. Line is, just look here, I'll do these later. Do you see it's a negative? Do you see your angle? Angle. All right. Not that yet. Let's just, without being too complicated. Now, guys, why I say we also bring the trig? It's not equals tan of 45. Angle of inclination is you know what? It's a special angle. So you agree is 1. So the gradient of straight positive, because look at it, the gradient is 1, there's my x plus c, and the y off, so it's going to be x minus 1. Plus 1. How did I get that again? Because tan of 45 degrees. All right. So that was just a bit, but don't panic. I'm going to do angle of inclination properly. Let's do 3.3. I'll start it down here. The Cartesian plane. We did time. Okay, I'll just keep an eye on that. And we have a line segment going across. The y-intercept you can see is -2, and up. Because 3.4, okay, I'll do my axes in black. So there are my plane. 3.5, Cartesian plane. Sorry, we're wonky there. 3.4, horizontal line, like so. This is parallel to this, which is -2 and -1. Now, if you ever have a straight line parallel to this, remember there, the x-axis is y is 0. So this would be a y equals 2 line. The gradient is 0. It's a flat surface. So it's 0x because the gradient is 0. And the y value, well, you can see is -1. So it's literally going to be the line equals -1. Think about it. On the horizontal x value of the coordinate will change. Y will always be -1. So we're going -1 down. That is the line y equals -1. If, on the other hand, you have a vertical line, like so, remember, this is the very strange one. This is where the gradient is undefined. So, just think of it this way. If your y-axis is the x equals to 0 line, put your ruler on the y-axis. That is where x is 0. Now this line, we've moved x to +3. Do we see that? We've moved x to the right. by exactly 3. So this is just the x equals to 3 line. So any line vertical parallel to the y-axis will just be x equals a number. And if I told you that that is perpendicular, we know the intersection of the axes are perpendicular. So I knew this was parallel. Do you see there the corresponding angles are equal? Or you could have said those co-interior angles are supplementary, they're up to 180, which means I know that they're parallel. Okay, the bell is going to go in literally 2 minutes. So I do 3.6. 3.6, a little bit reminiscent of 3.3, because with 3.6, okay, I have a straight line going through the origin, and I gave you the angle of inclination, which is 135 degrees, which is going to give, you can see it's adjacent angles on a straight line. To see the acute angle on the other side is 45. So the gradient is going to be -1. It is definitely, look, it's going in the negative direction. Now, some of you asked me on the group, if you went, for example, the gradient of the line is tan of 135, and then try to work that out, why would you then, you can see they were asking about adding 180s because the adjacent angles add up to 180. But I will do angle of inclination properly, but not even tomorrow. Maybe only on Thursday or Friday. Wait, today's Wednesday, Friday. All right, so this example, going to the origin is just y equals to minus x plus 0. Y equals to minus x, that line. Okay, now the bell's going to definitely
Less than a minute, ma'am.
How many? How many minutes, Chicken?
There's less than a minute, ma'am.
I thought so. So less than a minute. I just want to say I love you. Keep your spirits up. Don't be sad. What I'll do, I'll post the memo up to 3.4. Try 4, 5, and 6, and then I will carry on tomorrow. I love you guys. Stay positive. Okay. Mwah.